Well, hello everybody. Happy Tuesday. Welcome to Space Oddities. If you're new here, thank you so much for joining us. We hope you'll stay. We've got a packed show for you tonight. We're pretty packed anyway. But before we get on to what we're up to today, let me just welcome Michael and Roger. And those of you watching last week may remember our very special guest, Gurbir, who gave us a wonderful presentation on the Indian space program last week, which you should definitely watch on the channel because it was fab. And we welcome him back this week. And he liked it so much, he's come back. So this doesn't happen very often with us. So we're treating him with the exalted praise that he deserves. So welcome back, Gurbir. Nice to see you again.
Thank you.
And we have, very special people here, and we have Tom. So there we are. How are you, Tom?
Very good. Yes, very good. Had a crazy start to the week as always, but that's fine. That keeps me on my toes.
Fantastic. Good. So what have we got for you this week? Well, something that I was planning for this week didn't quite come off in time. What we're going to do this week, viewers, is to open the floor up to you, our viewers. We're going to do a Q&A session. So any questions that you would like to ask us about anything about the universe, please put them in the chat. And could I ask one of the team here to keep an eye on the chat and make note of, well, not make note of the questions, but just have a look to see what we've got. And anything you want to ask. I'm sure some of you at least have got some burning questions about the universe that you can ask us. We may not guarantee to give you the right answers, of course, but we will certainly do our best to answer your questions. So use this as an opportunity to answer ask those burning questions that you've always wanted to know about the universe. We will come to that a little later, but for now, put your thinking caps on and start putting your questions in the chat. And also tonight, we've got Constellation of the Week from Roger. Apologies it hasn't appeared recently, but we will carry on with Constellation of the Week. I'll let Roger tell you all about that a lot later. We have a bumper edition of Einstein of the Week this week because we didn't get around to doing it last week. But this week we have a bumper edition of Einstein of the Week, our weekly look at some interesting, shall we say, comments about not just astronomy, but science in general that I've come across on the internet. So I hope that'll all give you a good laugh later. If nothing else this week, it will make your eyes bleed. Let me promise you that. So we will get around to Einstein of the Week a bit later. But for now, what we're going to do is just go through the normal housekeeping. So first of all, I'd like to thank Gerard and Ian so far for donating to the cause. Thank you so much, gentlemen. Much appreciated. If you would like to donate to Space Oddities, you can click the super chat icon under the chat window. It's the one with the $sign on, and that will allow you to make a direct donation to Space Oddities. If you don't want to do that, another way of doing it is that you can buy us a coffee, because we have to keep our caffeine levels up here at Space Oddities because we work very long hours and very hard on what we do. And contributions in terms of the price of a cup of coffee, or 2 or 3, up to you, would be much appreciated. You can scan the QR code there, and you can also click the link that should have just appeared in the chat. Don't forget, we have Space Oddities t-shirts available and at our merchandise shop. These are £20, including UK postage and packing. We have a choice of 2 designs actually on the shop, the slightly older design and the new design. And these will cost you £20, which includes UK postage and packing. We've also got Space Oddities hoodies available. These are in 2 types, the ones that zip up the front and the over the head ones. Obviously, with the zip on, then the design is on the back of the hoodie rather than on the front. And these are £40, which again include UK postage and packing. And if you are outside the UK and you're ordering some stuff, then please add £10 to the total value of your order to cover overseas postage. You can have a look at all of the merchandise at the Space Oddities shop. And you can, again, scan that or click the link in the comments. May I remind you that allegedly summer's coming up in the UK, and it's a great time to get your T-shirts early for summer. Strut your funky stuff down the high street and advertise Space Oddities. And I'm sure you can't wait to do that this summer. that is the merchandise. Don't forget, just a reminder, in April, the whole of April on Space Oddities is going to be Moon Month. Everything we do on Space Oddities in April is going to be related to the moon. And we have got everything that you could possibly ever want to know about the moon, its evolution, its composition, all of the space missions. I think we've got videos about virtually all of the pre-Apollo space missions. We've got a whole load of stuff coming up. And let me just remind myself, actually. So what we've got coming up, we have, let's just flick back to the beginning. We have got, on the 1st of April, we start off with a discussion here on Tuesday, the 1st of April. That's next week. We're going to have a discussion about moon landing deniers, those people that for some unaccountable reason, best known to themselves, deny that the moon landings ever happened. So we're going to have a good old chat about that. That should be interesting. Hope you can join us for that. Then on the 8th, we have a very special guest from NASA talking about the moon trees. And if you don't know what the moon trees are, then tune in on the 8th of April and find out, because it's an absolutely fascinating story. On the 15th of April, Michael is doing a moon quiz. A quiz, everything about the moon. So another one of our legendary quizzes, and this one is about the moon. That will happen on Tuesday, the 8th of April. Then after that, on the on the 15th of April, sorry, that's the 15th of April. On the 22nd of April, we are going to be looking at the moon in popular culture to see how the moon has been viewed in popular culture, various things. That should be an interesting chat. And then the last Tuesday in April, we have a special about who's landing on the moon. All the countries that have got plans to send missions to the moon over the next few years, what they're doing, when they're going, where they're going, and why, all of that sort of stuff. So that will be on the last Tuesday in April, as well as all of the live streams in April, the 4 live streams. Oh, I think we got 5 in April. I think there are 5 Tuesdays in April this year. But anyway, apart from those, we've got all these other videos that we've done, everything to do with the moon, all the missions, all the people, everything. And I think we're going to be putting more or less 1 video per day on the channel in April about the moon in some fashion. So we hope that you would join us for Moon Month in April. We're really looking forward to telling you everything we possibly can about the moon, because this really is the year of the moon, as we've already seen with the IM-2 lander, God rest its soul, and the Blue Ghost lander, which conversely has been incredibly successful. You may remember we were talking about that last week and showing some of the footage from the surface of the moon from Blue Ghost. And we've got other stuff coming up for the moon this year. So this is a bit of a sort of a preview of what's going on with the moon. So that's Moon Month in April. I'm going to give you a preview of one of the videos a little later. But for now, what we're going to do is we're going to go over to the news. And lovely bits of news this week. So just give me 1 second while I set this up. Okay. Okay, hope you can all see that. Let's just come back here and get rid of our ugly mugs off the screen for you. Okay. There we are. Let's get rid of that. Okay, right. Okay, so this is the news for the 25th of March. The European Euclid Orbiting Observatory, which was launched several months ago now, has released its first major data haul, and it's absolutely amazing. The mission of Euclid is to understand the dark universe, that is to say dark energy and dark matter, maybe not explain it, but understand it a bit more. And it's mapping the whole sky, and it's already returned these spectacular images. I don't know if any of the panel can tell me what we're looking at here.
Einstein rings, maybe, or some galaxy things.
Yeah, absolutely. Well, it's gravitational lensing in general. There are some Einstein rings there. You're quite right, Tom. And this is just some of the data that it's come up with. And Einstein rings and gravitational lensing can tell us a lot about the history of the universe, as well as revealing, obviously, some objects that are much, much further away. And so far, Euclid has, in its first data haul, produced a map of 384,000 galaxies that it will measure in great detail. Each one will be measured in great details for its size and type and everything else. And that is only 3% of the area that it's going to cover in the sky. And it will be an unprecedented survey of the heavens from Euclid. So that was really exciting. PDS 70 is a planetary system in the constellation of Centaurus. It's about 370 light years away, I think. And last year there was the news that the ALMA telescope had produced this image showing this young star. It's only about 400 million years old. It's a young star. And as you can see from this, there are planets that you can see quite clearly. These are new planets being born. And there's the one on the right is a planet. There's one on the left, but as you can see, there's one here labeled possible co-orbiting companion. And this is strange because this seems to be two planets in the same orbit, which is quite strange in terms of orbital dynamics. However, there's new news. Excuse me. There's news about these planets a bit more after further study with the James Webb Space Telescope. It's discovered in the infrared that two of these planets have rings of material around them, which almost certainly are moons forming around these planets. So that's quite incredible. You can't see them in this picture because this is a radio image from ALMA, but in the infrared, these rings of material around two of the planets are quite prominent. And it's amazing to think that we can now look at not just planets orbiting other stars, but moons forming around those planets, which is absolutely incredible. So there we are. So that's PDS 70. You can obviously Google PDS 70 on the net if you would like more information. I haven't actually managed to see the actual web images yet, but I'm sure they're on there somewhere. So that's good news. Pluto, one of the big mysteries about Pluto and Sharon, or Sharon, or Karen, or Karen, or however you want to pronounce it. I pronounce it Sharon. Pluto and Charon are very interesting because they're almost a double planet. As you can see in the image, Charon, at the top left there, obviously, is a substantial size of Pluto itself. And it's been called a double planet system, really. So the question has been, how did they get together? Well, new ideas come up that not only might explain that, but might explain the existence of Pluto's underground ocean that we believe exists. The idea is that Pluto and Charon actually collided in the past, and they were born from the same cloud of material, if you like, but they actually not collided as such. They actually touched, and several people are calling it Pluto's kiss. And the idea is that they came very close together and then very gently touched each other for maybe as little as 30 hours and then separated again. And this explains these peculiar dynamics of the system. But also, one of the questions about this underground ocean on Pluto that we think exists is, with the low temperatures on Pluto, how did it not freeze? Because as far as we know, Pluto does not have an internal heat source. And the idea is that when Charon kissed Pluto, the heat generated from that was sufficient to melt the ice inside Pluto and create this ocean. And it's really interesting stuff. Of course, we don't know why the ocean. We don't know if the ocean's there, but all the indications are that it is there. because it accounts for the movement of the of some of the surface features on Pluto. But it's incredible to think that these two bodies actually once very briefly touched and then went their separate ways like spurned lovers, isn't it?
would that explain Tombo Reggio, maybe?
Yeah, it could be. Yes, it could well do, and it's the reason we think the ocean is there is because some of the landforms on Pluto do appear to be moving relative to others as if they are floating on something. So that's really interesting. We'll keep an eye on that, see if that story develops. Here's an interesting one. As you may know, around a black hole there is a so-called corona. This is a disk of incredibly hot gas, maybe 1 billion degrees, so extremely hot, that because of its temperature gives off copious amounts of X-rays, and that's how we managed to detect them. And this particular black hole, quite recently, that corona almost overnight disappeared completely. And astronomers could not work out why this happened. Its brightness decreased by a factor of 8 in about 10 hours. So, you know, for a black hole's corona to disappear, you know something major must have happened in that system. Well, what astronomers now think happened is that a star passed too close to the black hole and got pulled in. And all of that caused the corona to dissipate a little, lose some of its mass, and actually get pulled into the black hole. So the disk of orbiting material around the black hole, just all of it got sucked in. And then astronomers waited, and within about 6 months, the corona had reestablished itself. It was visible again. So there was a new disk of material orbiting, obviously so fast around the black hole it didn't get pulled in. But we've never seen this before. It would have been fantastic to actually be there and see that, wouldn't it? It must have been absolutely spectacular. The spaceship Lucy is on its way to an encounter this month with an asteroid called Donald Johanson. Now, that may seem a bit of a strange name for an asteroid, but I'm sure one of the team here knows. Michael, you probably know. Why is this this spacecraft called Lucy? Do you know?
It was named after a what do you call it? An archaeological discovery, I believe.
That's right. That's right.
Of a human female.
Yes, that's right.
The archaeologist called the female Lucy.
That's right. That's right. Lucy was a very, very early hominid, and a very important anthropological find. I can't remember the age of Lucy's fossil, but it's a few million years, and it's helped anthropologists certainly reinforce their knowledge about the family tree of humans. Lucy is seen as a very, very early, not exactly Homo sapiens, but a very early human. And the name of the archaeoanthropologist who discovered Lucy, you'll never guess, was Donald Johanson.
Yeah.
And the asteroid is named after him.
And Lucy is 3.2 million years old.
Thank you. I was about to say that. Yes.
Yeah.
Of course. Yes, the fossil Lucy, she was quite a small hominid, wasn't she? She was only about 4 feet tall, I think, or something like that. But yeah, Donald Johanson discovered her, and the spacecraft Lucy swings by Donald Johanson next month. It's a bit of a strange asteroid. We don't know that much about it. It seems to be quite elongated, sort of sausage shaped, and rotating very slowly. So a few mysteries there as to why and how that is. But the main mission of Lucy is to visit the so-called Trojan asteroids trailing behind Jupiter in its orbit. And in total, Lucy is going to visit 11 of those Trojan asteroids. And this is the second asteroid encounter from Lucy. And that's happening next month. We will, of course, cover all of that on Space Oddities when the flyby happens, and hopefully get some really good images of Donald Johansson, the asteroid, not the archaeoanthropologist.
Yeah.
So there we are. So we look forward to that in April. There's new evidence for life at Venus. Hot on the potential discovery of phosphine in the atmosphere of Venus, which you probably know if you watch Space Oddities for any length of time. We've talked about this quite often. If you don't know what this is about, astronomers think they discovered phosphine in the atmosphere of Venus. That was a couple of years ago now, wasn't it? Was it 20?
It's got to be.
Can't remember exactly when it was. Seems a long time ago.
I'm looking
In astronomy, everything seems a long time ago because there's so much happening. But phosphine is a gas that on Earth is only produced in the stomachs of penguins, although it can be made artificially. And at the time, we said this was obvious evidence for the existence of penguins in Venus' atmosphere. And we've been following that ever since. And in fact, our unofficial Space Oddities mascot is a penguin for that reason. And
I've just checked, and it's actually, can't believe it's actually 5 years ago this year.
5 years? No way.
No way.
No way.
Wow.
So that was pre-Space Oddities. That must have been Astro Radio.
Yeah.
Gosh, that was in our Astro Radio days. Amazing.
Yeah, wow. I didn't realise
Oh,
it was
I
that.
can't believe that. Anyway, so phosphine can be manufactured artificially on the Earth, but the only natural place it occurs is in the stomach of penguins. So obviously this caused a great stir among the scientific community, but the discovery was later found maybe not to have happened, or data was misinterpreted or something. There's been no 100% positive detection of phosphine. A couple of projects more recently seem to have discovered it as well, but it's not certain. However, this has spurred the United States into launching, I think it's 2 missions. Michael will probably tell you. Is it Europe's launching 1 mission and the US 1, Michael?
I believe so. I don't have the details of that.
No, I can't remember. I can't cram that much info into my tiny, tiny brain. But we think it's Europe's launching 1 spacecraft to Venus and the United States another to go and investigate this. Well, getting back to what this is all about, the new evidence for life at Venus is the discovery of ammonia in Venus' atmosphere. Never before found, but it has been found now. Ammonia, of course, is another indicator of life. Is it possible that there could be organisms living in the clouds of Venus that have adapted to the strong sulfuric acid, the hellish conditions in the atmosphere of Venus? Is it possible? Well, how do we know? We only have 1 example of life in the whole universe, and that's on this planet. We really have no idea what form life could take on other planets, and I'm sure that when we do get out into the universe, we're going to find some major surprises. The only thing that would really put the cat among the pigeons is that Venus doesn't really have water in its atmosphere, and we think that water is essential for life. So we don't know. I mean, this remains to be seen, but this is now stronger evidence that there is some sort of life floating in the clouds of Venus. We will keep an eye on this and keep you informed on that, obviously. And then lastly, the Atacama Cosmology Telescope has come up with the most high-res map of the cosmic microwave background. And this is part of it. This is the cosmic microwave background like we've never seen it before. If you're not familiar with what that is, the cosmic microwave background is, if you like, a dying echo of the Big Bang. It's the first light that was released about 380,000 years after the Big Bang, when the universe had cooled sufficiently in temperature to allow photons to freely travel across the universe. So it's the first light to travel across the universe, if you like. The orange areas here there are orange and blue areas. The orange areas are the warmer regions, and the blue areas are the colder regions. Now, when we talk about blue, cold and warm, we're talking about differences of maybe a millionth of a degree. So not a big difference, but we believe that these slightly warmer areas, slightly denser areas, were the seeds for the first galaxies. So it's very important to study this cosmic microwave background. Originally, it was light, but due to the expansion of the universe, it's had its wavelength so lengthened by the expansion of the universe that it's gone right across the spectrum into microwave wavelengths. So we now detect the first light as microwaves. And another thing that's come out of this, unfortunately, is that this new map of the cosmic microwave background confirms the rate of expansion of the universe as being 73 kilometers per second per what is it? I can't remember, but it's sorry, my mind's momentarily gone blank. But what it does, it means that the previous measurements of the expansion of the universe based on the CMB were accurate. This has reinforced them. The rate of expansion of the universe we get from looking at things like distant supernovae is 68. And what this means is that there's this big discrepancy about the expansion rate of the universe, depending which method you use. And this is known as the Hubble tension. And it's probably the biggest problem facing cosmology at the moment. So yes, it's 73 kilometers per second per megaparsec. So that's the expansion rate according to the CMB, but measuring distant supernovae, it's only 68. Now, people who've measured both have checked to make sure that their measurements were correct. They were doing everything correctly. They've gone through it painstakingly, absolutely painstakingly, looking for errors in the measurements, and they've never found any. So if you measure distant supernovae, you get one figure for the expansion rate of the universe. If you analyze the CMB, you get another figure for the expansion of the universe. And this is yet to be resolved. And it's, as I said, it's probably the biggest problem in cosmology at the moment. Basically, we have no idea why there is this Hubble tension, this discrepancy. Time will tell. So there we are. So that's the news for this week. And quite interesting things on there. So let's just have a look in the chat and see has anybody got some questions in there? Right. Yes, we have. We've got the Deep Burrito. Thank you for your question. And the question is dark energy slowly dissipating? Now, this is a good. Does anybody want to take that one?
I won't take it. I won't take it.
I can see you sneaking there.
Yeah, I snuck in the back door. You didn't see me.
Hello, guys.
Yeah, I distracted them and I snuck in the back door. The thing is, there's something that just came out this week that I actually saw, where they're saying that dark matter and dark energy, it as well as, because we know that the dark energy is what causes the expansion of the universe, or looks as though it's responsible for the expansion of the universe. And of course, the dark energy gives us the movement of of everything. Basically, it's filling the gap. But the thing is, there was something that came out. I wish I'd read it now. I didn't know this question was going to come up. But it did say that they reckon, and a new theory is that dark matter and dark energy periodically do decay.
Yeah.
Now, would this mean that because, as we know, when the expansion of the universe from the Big Bang, as we call it, it carried on quite happily, and then all of a sudden the expansion accelerated. And as you know, you've mentioned it before, as a phase change
That's
in
right.
the expansion. Now, maybe, just maybe, that phase change was when dark matter and dark energy started to grow again. If this theory is correct, I wish I'd read it, to be quite honest.
Well,
But the theory is that it does decay and it does disappear, but then obviously then it does it. They say it does it on a secular basis, but you know I couldn't explain it because I didn't read the thing now. But that's strange that this question's come in and it
yeah.
just this week. Yeah.
Can you say if dark energy was dissipating, then you wouldn't see the continuing acceleration of the expansion of the universe, wouldn't you?
So basically, what's happened this week, and I'm sorry, that should have been in the news because this is quite a major find. The dark energy spectroscopic instrument atop a mountain in Hawaii has just released its first full set of data for its first 3 months of observations, I think. And what it has found almost categorically is that the constant that we thought dark energy was is not, and it's actually decaying and has been decaying for a little while. So the weird thing about dark energy, Deep Burrito, is that you can't really say it's dissipating, because the weird thing about dark energy is as the universe has expanded, its density has remained the same, which is really, really strange. So it doesn't really dissipate, but its strength, if you like, over time appears now to be getting less, which means in the past it was much less. And it's a very, very interesting finding. If it's verified, and you know the evidence, I think they've got about a 3.9 sigma certainty for it at the moment. If that is verified, this will really, really upset the apple cart as far as cosmology goes. Because if dark energy was much weaker in the past, it raises all sorts of problems. And there are many things that we think we understood about the universe which rely on dark energy being a constant. Now, we know that the universe was not born with dark energy, that the effects of dark energy didn't actually start exerting this acceleration on the expansion rate of the universe till about 6 billion years after the Big Bang. So what Daz was saying, so about 6 billion years after the Big Bang, something happened that allowed dark energy to overcome gravity and to force the universe, which had been de-accelerating in its expansion before then, to suddenly speed up. Now, we don't know what that was. We may never know what that was, and it'll take a lot of thinking to figure that one out. The trouble is, when you're dealing with things that happened 6 billion years after the Big Bang, there's not a lot of evidence left as far as dark energy goes to show you what actually happened. So it's a really, really big question. But if the DESI data is correct, it's going to really put the cat among the pigeons as far as cosmology goes. So we'll have to wait and see whether it's verified. But at the moment, it looks so there we are. Weird times. And
Andy, can I just go on to this one as well? Graham's put on about Lucy.
yes.
Lucy was allegedly named because Lucy in the Sky with Diamonds was playing on the when she was discovered, I presume, on the radio.
Right.
And also, Paul says that Lucy actually has diamonds used in by one of the science instruments.
Oh, right.
Yeah.
That's fantastic.
Yeah.
Lucy in the Sky with Diamonds.
Yeah.
Yeah, because that is correct about they had Lucy playing.
Yeah.
It was because of course that's a Beatles song, and at that time they were very, very popular. So there was a good chance that a Beatles song would have been playing at that time.
Yeah.
But it just fits very nicely as well because
that's right.
Because we're going to look at the fossilized remains of the universe, looking at these asteroids and
that's
that.
Right,
so it all sort of like fitted together nicely. Because of course also Lucy passed a asteroid, didn't she? And they named the asteroid after the discoverer. What was this? Stronghoff?
Yes, that was
Stronghoff. I can't remember now. It was a Swedish chap name, wasn't it?
Yes,
Stevenson or Stephenson or
yeah.
something like that.
No,
Yeah.
you're thinking of the one it's passing next week. Donald Johansson.
Oh, is it next week? Yeah, that's it. Yeah.
I think it's next week or the week after.
Oh,
Donald
still
Johansson,
hasn't passed it yet. Oh, okay, then fair enough. Fair enough.
the guy who discovered Lucy.
Yeah.
So, but Daz, can you remember? It's already flown past one asteroid, and I can't remember the name of it. Oh God, there's so much info out there. But it's already done one asteroid flyby, definitely.
That's right, and it's the one where it found the two little moonlets. Yeah, they thought they found one little moon, and it turned out
somebody
they were
like to
twins.
Google that while we're sitting here, and because that's going to annoy me. I can't remember.
So what was that? Lucy flyby?
Yeah, look.
Yeah, and it found two little moons, didn't it? Moonlets,
there we are.
which was a big surprise.
The next question. This is from Pauline. Thank you so much for your question, Pauline. Is it possible that dark matter and dark energy don't exist, and there's something wrong with our theory of gravity?
Mm-hmm.
Yep.
Who wants to do that one? It's a basic yes.
Yes, because we it's the more evidence we get, the more things we can hypothesize, but also the more things we can rule out. And we've been looking at dark energy and dark matter for a little while now, and we're still none the wiser. We can map it. We can map where it is, and we can hypothesize where it is. We've got instruments in space that is actually mapping it at this very moment. I'm trying to think of the name. Is it Euclid?
Euclid, yeah.
Yes.
Yeah, that's mapping all the dark matter. There's several things mapping the dark matter, and it's basically just where it's sitting within the cosmic web and what's it actually doing. Because we know the universe, especially on the near to us, is clumpy. But when you look at the cosmic web, that is also with the web, the nodules. That's where all the matter's accumulating.
Yeah.
So and it's what I think what we need to know is what's happening in the voids.
Yes.
Yes, that's simple.
And this is where possibly where the expansion's coming from, because the matter is clumping together, and it's all moving in one direction, to what they call the great attractor. There is a name for it, but like Andy, I've got brain fade at the moment. So there's definitely something going on, and we don't know. We're striving to try and find out. And as I said, as regards the question, dark matter and dark energy, we don't know what they are, so we can't say that our theory of gravity is correct.
Yeah.
But I think it's worth highlighting. I think Pauline's making a significant point here that either it's dark matter and dark energy, or our theory is incorrect, and the existing standard model requires that gravity is correct if dark energy and dark matter do exist in the way that so far scientists think it exists and have the influence within the expanding universe. And if that wasn't the case, then they would have to review our understanding of gravity. So it has to be together. So Pauline's, I think the essence of your question is really spot on.
Absolutely. Yeah. Can we let's just talk about dark matter. Let's leave dark energy out at the moment. So there's another idea that our theory of gravity is wrong. And this is something called MOND, Modified Newtonian Dynamics. And what MOND says is that our understanding of gravity, especially how gravity behaves over long distances, is incorrect. And if you take that into account, you don't need dark matter, if you assume that gravity is not behaving as we think it does. Now, weirdly, what appears to be the case is that MOND, Modified Newtonian Dynamics, works well when you're talking about stars and planets and things like this, and even whole galaxies. You can actually get rid of the need altogether for dark matter with MOND in that respect. But when you scale that up, MOND does not work with clusters of galaxies. If you try and apply MOND to galaxy clusters, only dark matter works. MOND doesn't work at all. So it's almost as if you've got both things happening. And, you know, from what I read, scientists are slowly coming around to thinking that it's a combination of MOND over shorter distances and dark matter over longer distances where there's a lot of matter involved, like galaxy clusters. We've got humongous amounts of mass. So in the end, it may be a combination of the two. But MOND works well for a lot of things. Dark matter works well for a lot of things, but neither of them work well for everything. So it's a bit of a quandary at the moment. Obviously, it's a hot issue. Obviously, there's lots of research trying to nail down the nature of dark matter, exactly what it is. We think it's some sort of particle. Another thing that I saw this week is, I don't know whether you know this, but in the middle of the Mediterranean, there's a neutrino observatory, which goes down a good few kilometers with photomultiplier tubes, basically to catch the glow from neutrinos as they interact with water molecules. Neutrinos hardly ever interact with anything. They could pass through a sheet of lead 30 light years thick and not even notice it. But occasionally they do, very rarely. And they've detected a neutrino that, let me see if I've got this right, with the energy of 14 quadrillion electron volts, which is an incredible amount of energy. Never been seen anything like this before that went through the detector. And this, believe it or not, bears out something that Stephen Hawking put forward in the 70s, these primordial subatomic black holes. And Stephen Hawking says that when they shrink and evaporate, they actually explode and release incredibly high energy particles. And what scientists are saying is that this neutrino may have been one of those particles from a primordial black hole exploding. And if these primordial black holes, which are theorized to have been born during the Big Bang, they're much smaller, they're a thousandth the size of a proton. If they are out there, even though they're that tiny, they could have the mass of an asteroid. And if there are many of them, that could account for dark matter, these primordial black holes, because this could explain a lot of things. But this is very, very recent. This was only announced, I think, last week or the week before. The observatory in the Mediterranean has only just come online. It made the observation of that particle, that neutrino, within a couple of weeks of going online. So we expect more observations like this. And maybe this missing matter, the dark matter, is not a particle that we don't know anything about. Maybe it's primordial black holes, these tiny, tiny, tiny black holes born during the creation of the universe. So there we are. Daz, Dinkinesh. That was a lucid fly, right? Yes, Dinkinesh. Yes.
Flew by in November 2023, actually.
God, it's already 2 years ago. Oh, I can't believe that. Jesus.
That's what I said. I mean, because also we're talking about it. I mean, forgetting about Lucy. I mean, all these probes that are on their way to different places, and of course they're long term. We tend to forget about them because we're also something. I'm just going off a tangent just for a second. We've also got another lander on the moon coming up very soon.
Yes.
Is it Resilience? Is it called Resilience?
Yes.
It was, yeah. So, because that one's been going the long way to the moon.
Yes.
Been using gravitational assist and that. So, yeah. That's sorry, that was just going off at a tangent.
Right.
That reminded me.
Ian says, "Does all this mean that relativity is wrong?" No, relativity is not wrong. Relativity doesn't really come into it. So don't worry, Ian. Relativity is safe. Old Albert is safe. Okay. Well, don't forget.
Don't mess with relativity.
Yeah, don't mess. Yeah, don't mess with it. Don't diss Albert.
Please.
Yeah. Okay. Albert comes up in Einstein's of the week this week. Believe it or not. Anyway. So keep the questions coming in. We'll keep this going while we're on air. So please put your questions in the chat. We're going to move on now. And let me just have a look at what we're going to move on to. Right, we're going to go over to Roger now for our weekly look at the night sky and the viewers gallery. Do we have a big gallery this week, Roger? Can't hear you.
Mute.
Yeah. Is it your Bluetooth headphones again? Yeah.
Do you have the link, Roger? Have you got the link, Roger?
Have you tried turning it off and on again? Roger's gone silent. Praise the Lord. So, okay. Well, perhaps you won't go to Roger. Perhaps we'll go on to something else while Roger's getting himself sorted out. I mentioned earlier that we're doing Moon Month for the whole of April here on Space Oddities. Going to give you a preview now. This is a video that I've done about the whole question of water on the moon. Now, you know, years ago, if you said to anybody there's water on the moon, they would have laughed at you. But now we know that there is. So how did this whole thing come about? So this is about an 8-minute video, which I hope will allow Roger time to get himself sorted out. And this is one of our videos for Moon Month. This is water on the moon.
How can the moon have water? It's dry, it's dusty, it does not have weather, it has only the most tenuous of atmospheres. It's blazingly hot, it's numbingly cold. No clouds ever form above the moon, no rivers flow, no seas lap gently at lunar shores. 17th century astronomers gave the prominent dark areas on the moon the names of seas, like Mare Imbrium, the Sea of Rain. But they are not seas, they are plains of ancient lava, billions of years old. No soft spring rain will ever fall on Mare Imbrium. There's an ocean on the moon too, Oceanus Procellarum, the Sea of Storms. But no dark storm clouds will ever gather above it. So how could there ever be water on our beautiful natural satellite? One of the earliest proponents of the idea that there might be water on the moon was Harold Urey, a Nobel Prize-winning chemist who speculated in the 1950s and 1960s about the possibility of volatile compounds, including water ice, being trapped in cold regions of the moon. However, the concept became more concrete in 1961 when Kenneth Watson, Bruce Murray and Harrison Brown published a paper in the Journal of Geophysical Research suggesting that water molecules from cometary impacts or outgassing could migrate to and become trapped in permanently shadowed regions at the lunar poles. Between 1969 and 1972, the Apollo astronauts returned nearly 600 pounds of rock and soil from the moon. The samples underwent intense scrutiny from scientists around the world, a study which, nearly 60 years later, still progresses today. But no water was found in the lunar samples, confirming what scientists thought they knew, that the moon is completely dry. But then in 1976, the Soviet Luna 24 mission brought back soil samples with traces of hydroxyl, but this was largely overlooked. Hydroxyl, or OH to give it its chemical formula, is a molecule consisting of one oxygen atom and one hydrogen atom. It is not the same as water, but it is closely related. Hydroxyl can form when water molecules break apart or interact with minerals. In the context of the moon, it likely forms through interactions between the solar wind and oxygen in lunar minerals. It's a key indicator of water-related chemistry on the moon, even if it is not in liquid form. In 1994, NASA's Clementine mission detected reflections at the lunar poles, suggesting the possibility of ice deposits. Then, in 1998, NASA's Lunar Prospector found hydrogen signatures near the poles, interpreted as potential water ice. However, the images returned from both spacecraft were of such low resolution that the discovery of water could not be confirmed. This picture is a later image of the Moon's south pole by NASA's Lunar Reconnaissance Orbiter, the water marked in blue. But then, in 2008, reanalysis of Apollo samples by Brown University scientists found both hydroxyl and water molecules. It seemed that initial analysis of the Apollo moon rocks had overlooked them due to the inadequate analytic technology of the time. Then, in 2009, India launched their Chandrayaan-1 spacecraft to the moon. Mapping the moon's surface with an X-ray spectrometer, the spacecraft created maps of mineral deposits. But it also released a small impactor, which, striking the moon's surface, also detected both hydroxyl and water molecules. NASA's LCROSS mission, launched in 2009, aimed to confirm the presence of water ice in permanently shadowed lunar craters. The mission targeted the Cabeus crater near the moon's south pole, where previous data suggested potential ice deposits. LCROSS deliberately crashed its Centaur rocket stage into the crater at high speed, creating a debris plume. The LCROSS spacecraft, following closely behind, analysed the ejector before it too impacted the surface. The debris plume was also analysed by NASA's Lunar Reconnaissance Orbiter, or LRO. Instruments detected water ice along with other volatiles, confirming that significant amounts of frozen water exist in these shadowed regions. This discovery was a major milestone, strengthening the case for future lunar exploration and resource utilization, including human missions and potential in situ resource use. LCROSS provided concrete evidence that the moon holds accessible water, which could be critical for sustaining long-term lunar bases. There may be more than 1 billion tons of water ice locked up in the permanently dark craters at the moon's poles, where the temperature is a constant minus 230 degrees Celsius. So where did it all come from? Water-rich comets and asteroids bombarded the moon in its early history, particularly in a period about 3.5 billion years ago known as the Late Heavy Bombardment, depositing ice that became trapped in permanently shadowed craters. It may also have come from hydrogen in the sun's solar wind reacting with oxygen in lunar minerals to form hydroxyl and small amounts of water. There were also ancient lunar volcanic eruptions which released water vapour, some of which could have migrated to the poles and become trapped in cold regions. And the moon is constantly being bombarded with small meteoroids containing hydrated minerals, delivering water molecules to the moon over time. That water ice can be used by future human bases on the moon. It could be used to extract the oxygen from the ice for breathing, further processed to produce rocket fuel, be used for radiation shielding, agriculture, hydroponics, thermal regulation, industry and many other applications. All we need to do is to find the ice and figure out an extraction and transportation system, but there is no doubt that the ice is there in large amounts. In 2023, India's Chandrayaan-3 spacecraft landed at the south pole of the moon to search for water, but only detected hydrogen and oxygen separately, not as H2O. The US and Russia have also launched spacecraft to find the water, but so far their missions have failed. However, the US, Russia, China, India and Japan are all sending missions to the lunar south pole to search for the water over the next couple of years, so it's likely that at least one of those countries will find the water and eventually construct a base at the south pole of the moon. It's taken 70 years since the first suggestions that there might be water on the moon, but at last it looks as though we may find it and use it for the advancement of human lunar exploration. And there you have the story of water on the moon. Thank you for watching, and I hope you'll watch the other videos in the Space Oddities Moon Month series. Check out the Moon Month playlist on the Space Oddities.
It's a terrific job you've done there, Andy.
Thank you very much, sir. Thank you very much. So, yes, that was quite fun to do. So,
that's a good thing, because of course one thing we definitely need if we are going to set up bases is we need water, for two reasons, and that's to hydrogen for fuel and water. Well, basically you need the water to drink, but you need the hydrogen and the oxygen separated to make rocket fuel if we want to move on and press on out into the solar system.
Yeah.
So I mean, I can't believe that Lacrosse was 2009. Didn't think it was that long ago.
Oh God, yeah.
I can remember that happening. It was quite spectacular at the time.
It was.
Quite daring. So
long time.
Showing me age now.
God. Oh God, it gets worse.
Yeah.
So there we are. So that's the story of water on the moon. That is one of the videos that we'll be showing during our Moon Month in April. We hope you'll tune in. I did mention the Moon Month playlist at the end of that on the channel. That actually doesn't exist yet because we haven't uploaded all the stuff. We won't be doing that for well, maybe another few days, but certainly in April all the videos will be in the Moon Month playlist here on the Space Oddities channel. So Roger, while we're watching, that appears to have disappeared. Should we let him back in? Quick vote.
Yeah.
Go on then. All right. Welcome back, Roger. Testing, Roger. 1, 2, 3.
Hello.
Hello.
Hello. He's back.
I keep getting kicked off here. I'll have to load my presentations out for about the 5th time now.
Yeah, this is viewers, as you know, the perils of live broadcasting. So apologies for that.
He's alive.
Yeah. Paul Wheaton says, great forward thinking by NASA to save some pristine samples for later generations with better technology to study. The same is being done with recent asteroid samples. Indeed, because NASA only, God, it seems like months ago, it's probably years, but I'm sure it was just months ago that they opened a fresh batch, if you like, of moon rocks that returned from the moon, which had never been opened before, knowing that in future generations the technology would be better to study the moon rocks. So they've got pristine samples of the moon rocks to apply modern technology to now, and hopefully find out even more things that we didn't know before. Yeah,
just another one. I didn't catch all your news, Andy, because I was a bit late arriving. Did you see the Mars news and the discovery of quite a new long chain molecule in the samples?
I saw that actually. Yeah.
No, I didn't see that actually.
Yeah, I think it was only today it came out.
Right, long chain molecule, really?
Yeah, another long chain molecule. So it's sort of like zeroing in. So maybe, just maybe, when we get these samples back, we might be able to find something there. You know, just talking about sample returns and things like that.
That's
if
right,
we get these back, but yeah, they reckon that which one is it? It's not Opportunity, is it? It's Perseverance. It's discovered a very long chain molecule, but of course we found all of this on comets when we visited comets. I'm not what was it, P67? I'm not going to say the long name because I haven't got it written in front of me. I can say if it's written in front of me. But it's sort of like a Russian name. But yeah, we found some very long chain molecules on there, which are sort of like things that are needed to start life. You know, I think it was RNA or something like that. It wasn't DNA, it was RNA or something like that.
Yeah, it was RNA, yeah.
The precursor to making DNA. So the stuff's out there. The stuff's out there.
Yeah, absolutely. My personal view is that we are going to find maybe even the microbial life somewhere in the solar system within the next couple of decades. Because I'm convinced in places like Enceladus and Europa and asteroids, all the indications are that the building blocks for life are plentiful in the universe. We found things like formaldehyde and stuff like this in gas clouds. And, the question is, if you've got the ingredients, does it mean that life is inevitably going to arise from those ingredients?
No.
And what conditions does it need to turn into life? And we have no analog for this. We have no other life to compare life on Earth with. So anyway, there we are.
I reckon, Andy, that I'd go further than 2 decades. I think before this decade is out, we'll find something.
Oh,
really?
Nice.
So,
Would be nice.
Yeah, think about the pace at which space probes, particularly as we'll find out in April, this is so much happening on the moon. There's so much happening in the inner and outer solar system as well. And there's many more countries and companies launching stuff in there. The whole thing is accelerating. So,
Yes.
and I think the point you make is that these kinds of biological ingredients are there, and we just haven't found them. And as the pace of exploration increases, I'm pretty sure we'll find them, and it's pretty soon.
And just on your news about phosphine, Andy, the European Space Agency Envision probe build is scheduled for launch in 2031.
Really?
Yeah.
Excellent. Excellent.
What were the other ones? There was Da Vinci.
Yeah.
Yes.
There was another one, wasn't there? But I think one of them was dropped.
Yeah.
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 Phosphine. All of a sudden,
Yes, I think
everybody
yes,
wanted to go to Venus again. So
yeah. So we will see. Okay, keep the questions coming in, folks. We are still more than happy to answer any questions that you have about anything relating to the universe. We'll
I've
give
got
it
a question.
Go on then.
You mentioned gravitational lensing.
Yes.
Does anybody know who's credited with the discovery and when of gravitational lensing?
Was it Mr. Lensing?
well, Einstein, and that's why they're called Einstein rings, did predict it, but I don't know who's found the first one. I know. Sorry,
I only came across this very recently. It's a guy called Dennis Walsh, and he's from Manchester. So I always take the opportunity to kind of Manchester. And he discovered it through some follow-up observations from Jodrell Bank after an optical observation had been made, and he was trying to understand these rather complex multiple images that you get with gravitational lensing. And it was a discovery that's credited to him. He worked for a big. No, he always worked for NASA. Sorry, for Jodrell Bank, but it's just a name that not many people know about, and it's such an important discovery. So
yeah, damn right.
Dennis Walsh. He died sadly. He was born in 1933, and he passed away in 2005.
Oh, thank you for that. Well, that's something we didn't know. Thank you. I shall look into that. So there we are. Gerby, while we've got you, I think you had an announcement to make. Is that correct?
Not so much as an announcement, but just something that popped into my inbox, just newsworthy. It'll take about 4 or 5 minutes, and I'll just run through this very quickly.
Certainly.
It's a news item that relates to something called, we're so fond of acronyms in space. Here's a new one that it's only been around for a few weeks so far. ATLAC, and it stands for the Action Team on Lunar Activities Consultation. So, Action Team on Lunar Activities Consultation. Extremely boring, and it could very easily fade away because stuff that we like to see is, rockets launching or blowing up or coming back and landing on Earth, or discover amazing pictures from Perseverance from the surface of Mars. But this is really, I think, quite significant, quite important. So what is it?
Good question.
It's something that's initiated by United Nations, the Committee for Peaceful Uses of Outer Space. I don't know if you're familiar with that, UN COPUS. And it's something that it's been around since 1957. And they came out with this program to initiate ATLAC. And the idea is to establish through this new committee, I guess it will be, a framework of governance to see how the multiple countries and companies that are going to be exploring the moon, and how they will be able to work to a set of norms and standards, given the variety of different capabilities, objectives, technologies, and languages. And why it's needed now, I think it's something that you've already highlighted, Andy, in what you're going to be doing next month. There's just so much happening on the moon that, in the same way that the Outer Space Treaty was signed in 1967, before people got to the lunar surface, the idea is to get these standards and norms of behavior in place before everybody starts arriving there. And we had, in the last few weeks, a couple of landers on the moon, and I think we'll learn more. I've earmarked the date in my diary, the 29th of April, when you're covering all the missions are going to the moon. But here's a few. We've had a couple in the last few weeks. There's Hakoto, Japanese rover. There's another Astrobotics, I think.
Yep.
Orion 4 is coming in about a year or two's time. Chang'e 7, which is going to be really interesting, to return to your video, because it's going to have, in addition to a rover, one of the reasons why Chandrayaan 3 didn't find any water on the moon, and many others, because they operate on the lunar surface. And as I'm sure you know, the water is really down in deep craters where sun doesn't shine.
Yeah.
And what Chang'e 7 is going to take is, in addition to a rover, a sort of a hopper. And that hopper is going to hop into some craters, and it's got rocket motors as well. They'll come out again. So it's really, Chinese are taking this to the next step to discover and go to places where there is water, which so far human exploration hasn't, in areas that we haven't explored. And then there's all sorts of things with Artemis 2, Blue Moon with Blue Origin, and of course Starship. They all will be going towards the moon as well. So this requirement, or this desire to have some level of governance in place, is really to answer this issue of how will all these countries and companies organize and work together.
Right.
And this set of goals is, I just want to draw your attention to something else. We're familiar with the International Telecommunications Union.
Yeah.
This is an organization that allows you to allocate frequencies, not only for space, but elsewhere here on Earth as well. And we have the International Aircraft Safety, sort of Civil Aviation Authority, but an international version, the World Health Organization. You remember all the stuff they did for the whole world during the lockdown and COVID. The World Trade Organization, International Monetary Fund. So these are all global international organizations, and that's what really is behind, that's the intention for this action team for lunar activities consultation. And they said consultation is the key word. It's not going to be, it's very early stages, it's trying to get there. And the intention is that by the time activities happen. I just need to mention, in case you don't know, about the Artemis Accords and the International Lunar Research Station.
Yeah.
These are two almost competing bodies. Artemis Accords is the American, and there's about 50 odd countries that have signed up saying, yes, we will follow the guidelines outlined in the Artemis Accords, which are pretty much the same thing, or they have the same objective, to work on the moon together collaboratively and sustainably. But it's American. China and Russia, and that was set up in 2020. A year later, 2021, Russia and China set up something equivalent called the International Lunar Research Station. And ever since then, the other countries at large have either been opting to go with Artemis Accord, American, or Russia and Chinese one, the ILRS. And the intention, it's become a bit of a competition. And that's why this initiative from the United Nations is so, so important. And its ultimate goals is to really make sure, and it says this in the guidelines for ATLAC, that it's trying to make a compromise and make sure both Artemis Accords and the ILRS are accommodated, and that the balance is of activities is balanced between the two. It's really provides some sort of a glue between the two so far opposing and almost conflicting organizations. And so hopefully this will reduce the tensions between the two sides and hopefully provide us with a more collaborative working environment in on the surface of the moon. So not all countries are involved yet. This is just the beginning, and watch this space. It should be interesting to see how it develops.
Thank you very much.
Can I just reply to that, Andy?
Of course.
Yeah. I totally agree. We need, ever since, as you said, you mentioned the International Space Treaty, which was signed in the 1960s. Now, that's only ever been used once. And that's when the Russians accidentally crashed a satellite in Canada. And it's very long-winded. I mean, I think me and Andy did a long time ago a show on the radio about treaties and things like that, and there's been multiple treaties since then. But you can sign up to them, but there's no obligation to follow them, and this is where they've all fallen down. A lot of them have disappeared into the night, and like I say, because there is no actual policeman. That's the trouble. It's the same with space debris. We've got no official tracking regulations for it. So there is no one. I know there are people tracking the debris, and they're posting it up as much as possible, but there is no official body for tracking of space debris. So, as you said, we really do need some agreement. But then, as you said, we've now got the two competing projects. You got the Artemis, and then you've got the Russian and that one. Now, if we can come together, and this is what we're going to have, this is what's got to happen at some time. If we're going to expand out into space seriously and mine resources, do whatever we've got to do, expand out further and further and further, it's got to be done on a global scale. Not one country or a group of bodies is going to be able to do this on their own. So yes, I agree. I'm glad this is going on, and I hope there will be cooperation. Because I mean, one of the things you mentioned, the Artemis. Now, it was, if I remember right, it was actually Donald Trump who signed the Artemis protocols into sort of like law into the project. And one of them is that nobody can claim part of the moon. And then within 6 or 7 months or a year, he was saying that when they land on the moon, he wants exclusion zones around their bases. Now,
Right.
that was completely, it's that sort of thing that you've got to say negate. You say no, you can't do that. You're saying nobody can own the moon, but to have no-go areas around your bases
Yeah.
means you are claiming parts of the moon and that. So
And also does,
it
if you
sorry.
think back to the Outer Space Treaty of 1967, the two nations that didn't ratify it were the US and Russia.
Yeah,
So
exactly. Yeah.
so the whole thing was a bit
But
fun.
it's funny because I mean the laws about if things fall out of the sky, is who sues who.
Well,
And
the Outer
sorry,
Space Treaty, as you highlighted in that example, has been used. It does work, and it is a treaty. What this is, if you remember, it's why it got a weird name. It's the Action Team on Lunar Activities Consultation. So this is a consultation. Artemis is an accord, and we have multiple systems of guidelines. But treaties are things you're quite right, are things that governments keep well away from because there are legal obligations to that. But there is a great deal of work taking place.
yeah,
Just like with
I
space
agree.
it's in everybody's interest that we don't screw it up. And that's
Exactly, yeah.
I think the problem with the Artemis Accords and the ILRS has been that they've been either Russian and Chinese or American, and they've just not been able to come to some sort of a compromise. And with this coming from the United Nations, it was a necessary central cement, hopefully, through which the point you make, Daz, about making it work and enforcement is something that you can only do on a global level if there is a neutral body, a United Nations type body that can make this work. So it is something to keep an eye on.
Excellent. Thank you for that, Govia. That was a very interesting discussion. It's one I'm sure we'll return to in time as well. So anyway, at long last, look at his little smiling face there. He's so happy to be doing
Bless
this.
him, look, bless him.
Bless
and
him.
he's had a birthday.
Oh yes, happy birthday! Oh, yes, it was Roger's birthday yesterday. In case you didn't know, he was 107 years old, and very good. So well done. Okay. Just before he rushes off to change his colostomy bag, then we're going to get him to do.
Rude.
We're going to get him to do the weekly look at the night sky. His weekly look at the night sky, and of course the viewers gallery. Thank you for sending your images again. We'll talk more about that after Roger's told us what we've got in the gallery. So Roger,
Right. Okay, we're now into the final week of March.
Hey.
And the clocks go forward at the weekend as well. Boo-hoo.
Yay!
No. But we are experiencing up to Saturday where there's a new moon and also a, spoiler alert, a partial solar eclipse. But that will be later on in the announcements. Woohoo. So we are now experiencing the winter constellations now slowly setting into the western horizon, and galaxy season is about to start. So we've got Leo dominating the southern horizons and Virgo following up behind, and we're also starting to see some of the summer constellations coming through. So all's moving on through the year already. So should be quite an interesting week, I would hope, but it's a shame to say farewell to our winter constellations. Right, okay, so as we move further on through the week, we still get Jupiter and Mars quite nicely, but a lot of the planets are now becoming early morning objects to see as before sunrise, and that includes Saturn, Venus, Mercury and Neptune, although it will be mostly Venus that you will probably see due to the closeness of the sun, but there might be an opportunity later on for Saturn to be seen in the early morning skies as well. We just have to wait and see. But there we go. Right, so as we come up to the weekend, on Saturday we do have a partial solar eclipse. And fortunately for us, we do get to see some of it. Although knowing our luck, like 1999, it'll be cloudy. The forecasts aren't looking very good at the moment. But if you're in Scotland, up around Glasgow, you get a better percentage of 41%. And if you go down to Cornwall, it's only down to 36%. But they're still pretty good considering where we are at the moment. Of course, you won't be able to get a total eclipse anywhere on the Earth because probably the shadow is probably cast off over to one side. But it's quite well pronounced if you're in sort of Greenland or northeastern areas of Canada for the best optimum pictures. But that will be quite good. So that will be during the late morning through midday till a bit after. So get those special solar glasses out, and hopefully there might be a glimpse of it at some point during the eclipse. So we do have a gallery for this week, and we've got a couple from Ian McIntyre. He's got a couple of sunsets, and this is behind Craig Dunnan in Inverness, and he's got a interesting bit of colouring in the sky there. Very nice. And his other image he's also got of near Brora. I've never heard of that, but that's where it is.
Oh,
And
nice
a slightly cloudier sunset there, unfortunately. But well done, Ian, to capturing that. And Graham has got his trusty sea star out, and he's been doing some images of M100 and NGC 4312 to the right. And this was what he had with 2 hours of 10 seconds exposures.
Wow.
Oh, look at that.
Very nice.
Yes, got some nice spirally arms there.
Mm.
Very
Beautiful.
good. Very
That's,
nice.
that's amazing, isn't it?
Mhm. Very good. Well done. And then we've got Jerry with Thor's helmet. And
Ah,
this was done with a William Optics 61 scope and a 294 Pro, 40 times 5 minutes with his L-Extreme filter. And here we go. Look at
oh, very nice. Look at that.
Oh,
Lovely
that's really good.
detail in that.
that. Very nice. Very good.
Well done indeed.
Got some nice gas details there. Wonderful. Mm. Yes. And then we've got a nice picture here from Lee of M5051.
He's got
Now
himself.
he's bought a C Star because he's
Yeah.
just fed up trying to take his equipment out. So he's done the easy option out and got a C Star, and this was just under 2 hours of 10 seconds exposures in Alt Az mode. And here we go. And here we are, M51.
Oh, nice.
Fantastic. Well done, Lee. That's fantastic.
Mm.
Lovely colour.
Yes.
Well done.
Surprising how much you can get with a little C Star for 2 hours. Very good.
Yeah, just jumping in quickly. The C Star now, of course, it will track, but of course it doesn't take into account rotation. They've now resolved that, and you can do what they call use like as if you use an equatorial mount.
Yes.
You through the new system, the new programming, you can now do that to accommodate that. All you need is an equatorial mount, or even you can do it with a rollable head on a tripod. So these things are only going to improve.
Yeah. Yeah, I think it shows on the actual C Star. If it's green, it's in equatorial. If it's red, then it's in Alt Az mode.
Oh, right.
You have to set it up.
Yes.
Yeah, you have to set it up.
Oh yes,
but
but,
it can by doing it. I've seen it on the YouTube, and it's very, very simple to do. But literally, if you just follow the instructions on the Sea Star, within minutes you're taking shots, and then all you can do is just leave it all night, and it will track that, taking in rotation and everything, so you can get very, very long exposures on there now. So I just thought I'd chuck that in there. So yeah, so
No,
now
that's
you can
fine.
do yeah.
Okay. We've got a few images from Kenneth in Norway over the previous few nights, and he's been having his usual sessions of Aurora. So he's been using a couple of different Canon cameras. He's been using a EOS 1D Mark III, and he's also had a EOS 50 Mark II with different lenses on, and he's been rather successful with some of his images.
Oh, nice.
Oh,
That's
lovely.
Oh, don't worry, there's some more to come. He's been rather lucky over the last 6 months or so with Aurora. It's been absolutely
Yeah, the
amazing.
last few weeks, it's been virtually every night up in the northern hemisphere. Right up at the North Pole.
I'm
so
sure
like
Kenneth might get a bit fed up with it again. You know, do I have to?
every night keeping him up.
Yeah. And this was another one where it was slightly stronger, and
Oh,
Yeah,
lovely. Gosh,
Beautiful, isn't it?
beautiful.
yeah.
Beautiful. Well done, Kenneth.
Mm.
Lovely. Beautiful scene.
Yes. And he's got another one which was done a few days before this, so on the 21st. And it wasn't quite a very high value on the scale, but he still managed to get this.
Wow.
Oh,
Lovely.
That is lovely. Well done, Kenneth. Thank you for that.
And I see on the social media this evening from about 8 o'clock further up north, there was some quite amazing aurora going on at that time about 8 o'clock. So
all right.
it's
Can I just
obviously,
jump in again? Just jump in again. Tonight, they may come down into the lower latitudes.
but
Everything
there
being
might be
correct.
opportunities tomorrow as well, I think.
Yeah, exactly. Tonight and tomorrow. They did. I'm just checking now. I just want to check the BZ. So if you just bear with me a second, I'm on the wrong thing. There we go. Just there. Scroll down. Let's have a look at the BZ, because of course we need the BZ to be a southward component, and yes, it is. Oh, yes, it is. Yes, quite a lot in the south. So keep an eye on your alerts, or keep an ear out for your alerts, and maybe, just maybe, things might be good for us tonight.
Okay.
And I can tell you in a little while why this is all happening. So won't be a second.
All right.
Okay.
Okay, and last one is one from me. I managed to get outside during the daytime and get some activity on the sun. So this was what I managed to get, although I didn't quite get it all. I chopped a little bit off, but there were some interesting prominences that were sort of suspended above. And got some
indeed. Yeah, well done.
So it was getting a bit late in the day, so I was getting trees and stuff in the way, so I just quickly grabbed what I could. And
those proms are great, aren't they?
they've been amazing. They've been something similar again today, but nothing I've captured. But that's what we've had in the gallery.
In fact, they say it might quieten down tomorrow, so tonight could be the last night of the proms.
Oh dear.
Oh.
Okay.
I can kick him off if we want. Can we have a break?
I
thought that was exceptional quality. Then.
Oh, thank you. You see, I've got somebody here who doesn't
Don't encourage him.
Yeah.
Okay, so anyway.
Right. Thank you very much for that.
Thank you very much.
Thank you.
Yeah. Can I just sort of like? Sorry. You want to say something, Andy?
Two things. Firstly, can I just say thank you to Paul Burgard for his donation? Very kind of you, Paul. Much appreciated. And secondly, I've quite forgotten what the second thing was. So,
right.
Well, can I just say two things about the sun, Andy? One,
yes.
we hope to cover the eclipse from,
Yes.
well, hopefully from my back garden, weather permitting.
Mhm.
We
On
hope to
Saturday.
cover it, and we hope to put it live on YouTube. We'll start from me. First contact is 10:05. The maximum will be at 11:02, and then final contact will be where it leaves the sun's face will be the 1 minute past 12. So weather permitting, we hope to actually broadcast this live
Yeah.
as it actually happens. And we're going to have, I think we're going to get sort of like about 38, 39%.
Yeah.
So fingers crossed that this all comes together. But as I said, it's all weather permitting.
Yeah.
And also as regards the sun, I haven't done a thing, but we are officially now past. We're on the decline. We're not past the maximum, but we're on the decline. Now, don't worry, because this means that we can still get solar storms like tonight, hopefully. And I don't think I've got I've got a picture at the moment that I can easily get to. But the one thing that is facing us, and this is what's got causing what's a lot of what's happening tonight, plus a few very minor flares. But there is a coronal black hole, which I would say is covering 25% of the solar disk. It's in the southern hemisphere, and it actually does stretch across the equator, and it's absolutely massive. And of course, we know when you've got black holes, the black holes, when we've got coronal holes, we get enhanced solar wind, and this is why Kenneth has been bombarded with virtually night after night, all these auroras. But tonight, with a couple of other little things that have happened, it may get big enough that the solar storm will hit us, and then we will hopefully get some aurora. As I said, the BZ, the magnetic field around us, is in a south position, and that's what we need to actually get aurora. So that is actually in the right position at the moment. But that's what it is. I mean, at the moment, we have got some really massive. I mean, this one major black hole literally is covering. Last time I saw it was in the center, and it's covering at least 25% of the surface of the disk. Plus, there's some small ones either side. And those prominences you saw, Rog, last week we were in the teens for active regions alone. They were absolutely, they were from sort of like 10 to 13, 14 active regions at one time on the sun. The only thing is that they were all only producing very small. There were a couple of M class, but they were low level, 1.2s, 2s, and things like that. But with the coronal holes now, we could be coming back into a period of high auroral activity. So just keep an ear out for your alerts, and hopefully everything will go right and we'll get to see them. So
and also we are going live on the channel on Saturday morning. I have actually put Daz, you'll be able to tell me, we've actually got UK time 8:45 for going live on Saturday. Is that correct? That seems a bit early to me.
8:45. No, that'll be because it doesn't the first contact, as I said, is 10:05, so that should be 9:45.
9:45.
Yeah.
So around about that time. So
okay.
And again, that all depends whether or not we've got the weather. I mean, I've just looked at the forecast and it doesn't look that good, but we will see.
Okay, so 9:45 on Saturday morning, weather permitting, we'll be live on the channel from Daz's garden, covering the eclipse. Oh, there's nothing like live broadcasting.
Yeah, bring some shears and a mower, and we can all. If it is a bit cloudy, we can do a bit of work, and it needs a bit of a tidy up. So,
just Kenneth says something here. There we are, Daz. BZ is -5.
Yeah, that's what I've just seen. Yeah.
So there we are. Michael, you wanted to say something about this, I believe.
Yeah, I do. I've got a few more details about the eclipse, actually. Just bear with me while I share my screen.
Mm-hmm.
Let me find out how I'll do it again. That one, share. Okay, you got that? Yeah.
Yeah.
So this is the few more details about the eclipse, partial eclipse on Saturday, the 29th of March in the United Kingdom. As we said, various parts of the UK will get different coverage. You'll get 34% in Birmingham. Further north you go, like Glasgow, 41% eclipse. But down in London, 30%. So we're just about in the middle here in the Midlands. But yeah, it's still worth having a look to see the moon going in front of the sun.
Yeah.
Okay. I have a question about that, actually.
Mm-hmm.
Why is Southampton, which is further south from London, seeing more of the eclipse?
Good question. I don't know.
I think it's to do with the actual path of the eclipse itself.
Probably.
It's curving.
Yeah.
It's curving.
Yeah.
The way it's curving round and that.
Okay.
But also, can I just remind everyone: do not look at the sun without any aids.
Correct.
Make sure you've got proper glasses.
Yeah.
And if you're using photographic equipment, make sure you've got the correct filters.
Yeah.
Don't be tempted to use things like welders' masks and things like that, because unless you've got this the right specification, they only cut out so many wavelengths. And you need the really expensive ones to cut out all of the wavelengths, because you'll still end up damaging your eyes if you're using a welder's mask if it's not the right specification with the filter.
Yeah.
So just be very, very careful. Of course, there's many ways you can project the eclipse onto the ground or onto a piece of paper,
Or a calendar.
your colander, or one of the best ways, if there's no wind, get yourself a non-stick saucepan, fill it full of water, and then just look at the reflection on the actual surface of the water. You will get if it's a non-stick one, it's a matte finish, and you will get a perfect view of it. And just take photographs of that. It's very, very safe. Just make sure, but don't look at the sun with the naked eye, please.
No, exactly.
And just as a reminder, this is a diagram of what's actually happening. The moon is actually moving in front of the sun as we view it, and it will cast the shadow on the Earth, which is what we see as an eclipse.
Yeah. There we are. Okay.
Hang on, and this is just another image of an earlier eclipse. Okay. So just one other thing. 10:30. This is the eclipse as it would be viewed from Darlington. 10:30 on the left, 11 a.m. in the middle, 11:30 on the right.
Fantastic. Okay.
And I just want to remind people that on the 31st of May, Saturday, 31st of May, at the Institute of Astronomy in Cambridge University, the Federation of Astronomical Societies has their first convention in a few years, actually, for various reasons. Tickets are still on sale for that, priced at £10 per person. They are more than 75% sold out now. But we got a few different speakers on there, including Lord Martin Rees, the Astronomer Royal, and so 5 speakers altogether, with different subjects. So yeah, that's on the 31st of May for anyone's interested in that. Okay.
Great. Thank you very much. Okay.
Right. That will do.
I did see Ian had a question. I don't know where it's gone.
But just answer Ian's question. Ian wants to know about multiverses, and specifically, he asks, how big are they? This is impossible to tell. we don't even know that they exist, let alone how big they are. And we can never really know because we can never directly detect them. There is an idea that due to something called cosmological inflation, which, if you follow to its logical extremes, means that multiverses do exist. There's no direct evidence that they do. We're not likely to have any in the foreseeable future. It's just a consequence, a natural consequence of cosmological inflation, that there's this thing called eternal inflation, where you have, if you like, bubble universes coming into being. Some of them, or maybe most of them, we have no idea of knowing, will immediately collapse again, but occasionally one will survive, like our own universe. And they're in a much bigger medium, if you like, called the multiverse, which consists of all of these different universes. But this is way beyond blue sky thinking. This is, something that, as you said originally in your question, it's might be more in the realms of philosophy. But there are a good many scientists who think that the multiverse exists, and that these baby universes grow like ours, and they either grow or they collapse again. So time will tell, I guess. Time will tell.
Because it was like that question we were talking about after the show last week about this. It's an old theory. It's not a new theory. It's been muted before. And the universe actually is the center of a black hole. We actually are sitting in. We were talking about this last week, and we were trying to sort of like get our heads wrapped around it. And we are sitting inside the singularity. Excuse me. A singularity of a black hole that is the center of another galaxy. So it's like a nest of Russian dolls. But the thing was, we were saying, and this was from looking at I think it was James Webb images of the going way back into the past, and they studied 263 solar systems, not solar systems, galaxies, and they were the reason they're saying that is that only a third of them were rotating anti-clockwise, and a third of them were rotating clockwise. And the reason they're saying that this is possibly an indication of that we are inside a universe that is spinning itself inside a singularity of a black hole. So it's further proof of it. But my thinking was, and when we were talking about it, is you can, when you look at galaxies and you look at their spin, it all depends upon the perspective you're looking at. There is no up down, there's no left right. So if you're looking from, say, the south, it could be rotating clockwise, but if you go north and look down, it'll be going the other way. So I can't understand how that can be an indication that, and of course this all goes back to what they call it, Andy? Entropy, where everything's got to be doing the same thing in all directions.
Right. Yes.
Yeah, and homogeneity and things like that. If you look in each direction, everything looks the same.
Yeah, there we got anistropy and homogeneity.
Yeah, that's right. And they were saying that you should have 50-50 if you look at the galaxies. Well, you could have just been unlucky, but then again, also, like I said, you've got to look at perspective of how these galaxies are presenting to you.
They must have a way of discerning this, though. I mean, that they must.
Yeah. But also, it also adds to my thinking that if you are in the if our universe formed inside a black hole, inside the singularity, then that means there must be somewhere, and we're expanding, there must be a center, which we all say there isn't a center, because everywhere you look, it's the same in all directions.
Yeah.
And also that means if you are in a singularity, there must be an edge. How far can it go before it gets restricted within this singularity? So yeah, it's just one of these things. It's just one of these thought processes that go through your head.
Yeah,
and that. But yeah, so
yeah,
multiverse is
nobody
sorry.
knows, and we're not
No,
likely to know in the foreseeable future.
Yeah.
Okay, let's move on. I think we'll give Roger a bit more of a rest. I think what we'll do now is go to Einstein of the Week, and then we'll come back to Roger afterwards. Now, Einstein of the Week, as you may not know or may know, is our weekly look at comments on social media that people made, not just about astronomy or astrophysics or cosmology, but sort of general science things as well. And it's a bit of a laugh. We keep the comments anonymous. We don't want to name and shame anybody, although it's tempting. Anyway, without further ado, I'd like to present to you Einstein of the Week. So let me just put this up on the screen. Come back here and just get rid of us. Okay, so a bumper edition of Einstein of the Week this week, because we didn't do one last week because of time constraints. But anyway, Einstein of the Week. These are comments that people have made on social media about the universe, anything to do with the universe, or perhaps more general science things. So we start off at number 13. Some of you, like us, will remember Apollo 9. Well, this was in the same year that Apollo 11 landed on the moon in 1969. And there you see a lovely photo of Apollo 9 on its way to be launched. And somebody appears to be stuck in 1969 on social media because their comment was, hoping everything go well. Bless. Yeah, isn't that lovely? So that's in at number 13. Number 12.
They mean well.
This was a gentleman who got his knickers in a twist, because it turns out that the way that lunar eclipses actually happen, and this was in relation to the recent lunar eclipses, the way that lunar eclipses actually happen is not what the Quran says happens, and he blames astronomers for that. And here's what he wrote. He wrote, "And I swear by he who raised the 7 strong things and fixed the earth with pegs and destroyed Thamud and Ard, that if the astronomers who are hindering others far away from the sign of overtaking," presumably not that one, "don't stop, consequently Allah will make a whip of chastisement before them, so he would punish them with a punishment he has not punished anyone among the worlds. Then he would transform them," the astronomers, "into pigs and curse them with a great curse." So anybody who's thinking of going into astronomy as a career might want to think again if you're going to end up being converted into a pig. So there we are. So I just thought because that one just tickled me.
I pay good money to get talked to like that.
Yeah, I'm sure. Number 11. Somebody's not a fan of Saturn. This is in relation to that wonderful recent infrared image of Saturn by the JWST. "I drown Saturn and their everything, everyone, everywhere with the blood of Jesus Christ in Christ Jesus' name. Amen, 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 amen." So there you are.
They missed one.
Yeah.
They missed one.
So somebody's going to be drowned, or Saturn's going to be drowned. Number 10. Yeah, you may know about the Murchison meteorite. This is a meteorite found in Australia that predates the Earth. It's older than the Earth. Very important meteorite. And the comment was, if it was formed before the Earth, where did they find it?
What?
Yeah, exactly. So that's a lovely one for you. Number 9, somebody else having a rant against Blue Shepard. Blue Origin's, sorry, that should be New Shepard, not Blue Shepard. Blue Origin's New Shepard spacecraft, the one that takes space tourists up on a suborbital hop. And according to this person, they shouldn't keep launching it but it's burning up our oxygen, solar rays, and radio waves.
Oh, wow.
Yeah, I know.
Oh, so we're doomed. We're doomed.
We're doomed.
We're doomed.
Yeah,
How can it
so
be
there you are.
burning our
Stop
solar
launching-
rays?
Stop launching New Shepard. So, yeah, I know. I can't work that one out. Number 8. number 8. This was in a conversation about nuclear physics, and this really I love this one. I now live in Spain and worked in, I think, nuclear power stations for over 40 years, and I'm English. So they worked in nuclear power stations for 40 years, but never learned how to spell it.
Yeah. Yeah.
Oh God, that's going to look good on the CV, isn't it?
Yeah. What's your work experience? I worked in nuclear power. To be fair to this guy, I did actually make a sarky comment that he hadn't learned how to spell it in 40 years, and he claimed that he hadn't got his glasses on. Anyway,
Right.
make
But
of
he
that
got every
what
other
you
word
will.
correct. He got
So,
every other
to be
word
fair,
correct.
Okay. Anyone for fossils? You may have seen this in the news that not long ago they discovered a fossil of a plesiosaur with fossilized skin, and lots of people couldn't get to grips with the fact that it's not real skin, living skin, it's fossilized skin. But this was an amazing find because the skin had incredible detail. Anyway, somebody wasn't impressed. Fossils get discovered with skin more often than people are told, but it gets hidden because evolution is the cash cow.
Oh, too much Jurassic Park going on there.
Yeah. Yeah.
And again, they couldn't spell it.
I'm sure.
Is that the right spelling of fossils anyway?
Yeah, I love that, fossils.
That's the American way of spelling it.
Yeah.
I was just going to say, because I was just going to pull Andy over the coals saying we're mocking that bloke with nuclear, and Andy's got it wrong, but it isn't. It's actually in the text.
It's actually in the text. Yes. So I think anybody who works in evolutionary science would disagree that evolution is the cash cow.
Yeah, very much so.
Yeah, definitely.
Yeah, very, very poor.
Yeah.
Poorly paid.
Anyway, now coming in number 6, somebody who doesn't quite understand light. This was in an article about the stars of Orion's belt. Thanks for your reply. However, if those stars are thousands of light years away, how did the ancient civilizations could have had any clues about them? That's not how it works. That's not.
No, unfortunately.
And number 5, again, somebody not understanding light. I think I inadvertently captured Andromeda last night, took a photo in the direction of it, looked closer this morning, and I'm pretty sure that's it. Blows my mind to think that this little iPhone can capture photons of light 2.5 million light years away. That's not how it works.
No. They've come to you.
They come to you.
Yeah.
Okay, right, we're in the top 5. Now, people have tried for many decades to come up with reasons why Einstein was so gifted, why he was so intelligent. You may remember that they removed his brain after he died and looked for differences between his brain and other people's brains, and they couldn't find any. But this person thinks he has the reason why Einstein was gifted. Einstein was circumcised since his 8th day. Perhaps his circumcision since his 8th day had affected his thinking.
Okay,
So now we know it was all down to the circumcision.
Wow.
So there you are.
So
Okay.
he made the cut.
Yeah.
Okay.
Number 3. What's a telescope? Just stories. If you haven't been out of the Milky Way, how do you know what's far beyond?
Oh dear.
Okay.
Yeah.
Okay.
It's not how it works.
That's not how it works.
Yeah, if you sit under a rock, you won't see any stars now.
Yeah.
True. Okay, number 2. Words fail me with this one. Nobody knows anything beyond the planet Earth.
Is that right?
Oh,
Apparently.
interesting.
Yeah,
Okay.
apparently. So, nobody knows anything beyond the planet Earth. There we are. So you can say goodbye to 3,000 years of astronomy. That's
Well,
completely
science, basically, any sort of
science. Yeah,
phenomenon,
basically.
so.
Okay, so number 1, Einstein of the week. And
roll.
you won't believe this one. This one's actually about vaccines. I warn you.
Oh. Mm.
But it's an interesting question. What if instead of a vaccine, we just were able to get exposed to a weak version of the virus that enabled us to build the antibodies we need to fight the real thing?
That is a vaccine.
Exactly. Yeah. Yes.
Right.
It makes
How
you.
do these people manage to get out of bed in the morning and not die across the road?
I don't know.
Well, all I can say is good job breathing's an automated system within our bodies, because they'd soon forget, wouldn't they? It oh well, you know, we shouldn't mock it because they make us look really intelligent. So
Which in your
yeah.
case is difficult, admittedly. So
it is. I mean, yeah, you know, I set the bar so low.
The bar's on the floor. So there we are. Anyway, that's Einstein of the week. We'll have more next week, I'm sure.
But they've enjoyed them in the comments. They've enjoyed them.
So yeah, did they? Oh, good. Let me just read the comments. Yeah. So there we are. And Paul says, in my country, these people vote.
They do here as well.
Yeah, absolutely.
Very good.
So there we are. All right then. So what we're going to do now, we're going to go over to another weekly feature, Constellation of the Week, and this is Roger's turn this week. So Roger, which constellation have you got for us this week?
Right.
Before we start, Roger, apologies, I need to get going. Lovely evening. Thank you very much indeed, and I'll catch up with you again soon.
Oh, it's lovely. Drop in whenever you want to. You're always welcome. You know that.
Appreciate that. Thank you.
All right, take care of yourself. Have a good week.
Bye.
Bye.
Right. Oh, look, it's Leo this week. Okay, so here we go. Well, I thought I'd do Leo as it's currently getting quite well viewed at the moment and part of the galaxy season. So here we go through. It's not a bad size constellation, obviously recognized over on the right hand side with its sickle shaped stars at the front, with Regulus being the alpha brightest star of that constellation, but we will get through the details as we do. So it's currently magnitude 1.34 and 77.5 light years away from us. So that's at the bottom of the sickle, so they say. Okay, so at the back end of the constellation here is Beta Leonis, which is Denebola, and that's.
Is that how you pronounce it? I always say Denebola.
Oh, well, that's how I'm saying it. So there.
Fair enough.
Magnitude 2.23, 36 light years from Earth, so they're not all that distant away from us. So that's interesting to know. Algeba, which is the third brightest star, magnitude 3.6, and it is a double star, a binary star. So that has a period of 600 years. So we've yet to see that do one orbit around there, but it's 126 light years away, so a bit further away than some of the other stars. And then Delta called Zosma. That's an interesting one. I never knew its name, but that's 2.58 and 58 light years away. And here are the other brightness of the other constellation configurations. Okay, but obviously Leo and the adjacent Virgo following on behind it is part of what we call the galaxy season, where they've got clusters and clusters, thousands of these interesting types of galaxies that they are all contained in. First one we obviously know a lot of people will be familiar with is the Leo triplet. That's its rough position down on the map on the right, and one of my photographs of the Leo triplet on the left hand side. So we'll go through the details. The first one is NGC 3628, otherwise known as the Hamburger Galaxy. So that's its designation, although it is next to two Messier objects. So I don't know why Charles Messier missed out on that one, but
Yeah, that's strange, isn't it?
seems very odd. But yeah. So it's looking a little bit weird with its shape there, because it's interacting with the other two galaxies. So it's being sort of pulled out of shape, unfortunately, a little bit there. So, but the dust lanes are quite distinct on the. If you do manage to see it through a telescope or take some images of it. The other one here is M65. And we've also got M66, which is that one. And that one's a little bit more colourful, and I seem to pick up some interesting colours on that as well. But it's quite an interesting thing. So they're sort of all interacting with each other, so we get some interesting shapes here. So
beautiful,
amazing, aren't they?
Yeah.
So. Further over, we've got M95, and it is a lot fainter, unfortunately. It's 11.4, so you do need a larger size objective to be able to capture it. But we get some interesting shapes, and there's a slightly more fuzzy object here, but you do need an even larger telescope to be able to see it, to get any definition, but they are all there, and we've got this tiny globular galaxy here, which is on the Messier list. So we've managed to correct some of the objects from that area for his catalogue. Okay, and then well, that's all. That's it.
That's it.
Right.
Oh,
Yeah.
Lovely.
So there are quite a few interesting objects there. I've only just touched on the most popular ones, but if you really want to get more involved with it, then you can just get carried away just pointing anywhere really in the region of Leo, and you're bound to pick up quite a few galaxies. One shape, size, and distinction and category anyway.
Absolutely.
Because you mentioned Messier there. Well, of course, he was a comet hunter.
Yeah.
And he used to get distracted by fuzzy objects.
Mm.
So what he decided to do was to log them. And that's where we get the Messier index from. There's only about 100 and something or other. 110. But also we're in Messier season, aren't we?
Just about, yes. So you
Yeah.
have to be fairly quick now.
That's basically where, if you have got a nice clear sky, a nice horizon, you can pick up literally all of the Messier objects. But I think there's just one, only if you're very far south in the UK, that you'll actually pick it up, because it's a dawn object, and you have to be that far south to be able to pick it up. But it's a fun night. You have to plan it, because all the different Messier things appear at different times. And you have to start in the west, and you usually end up towards the east, sort of thing, as you go across, trying to catch them all and all that. It's a very long night, very exhausting, but it's fun, especially if you can catalogue them yourselves. So yeah.
There we are. Oh, Anne in Hout in Dublin says that she's getting Slight Aurora.
Oh, nice.
Dublin.
Oh, that's good. That means we should be able to might get something here.
Yeah, fantastic. Thank you for that. Thanks for letting us know. So if you're in the area, get out there in Dublin and have
gallery for next week.
Sorry,
Gallery.
Get it in the gallery for next week.
Oh yes, absolutely. Get some photos if you can, Anne, and put them in the gallery. So there we are.
Yeah.
Right then. So I think we will start drawing things to a close this evening.
Yeah.
We'd like to thank all of you for your questions for our Q&A this week. But don't forget, you can ask us questions anytime. We don't have to do a special edition for you to ask your questions. Anytime, put any questions you like in the chat, and we will do our very best to answer them. I'd like to thank Michael, who's transformed into a SpaceOddities logo, for being here. He's a transformer. And Tom, nice to see you back, Tom.
Nice to be back.
And Roger, thank you for your contributions this evening, Roger. And welcome back, Daz, to Space Oddities after a bit of a break. But lovely to have you back, Daz. And there we are. So don't forget, we're going to try and cover the eclipse of the sun on Saturday.
Fingers crossed. Fingers crossed.
Fingers crossed. 9:45 UK time, we'll go live. But if you go to the channel and you don't see the live stream coming up, it means we've removed it because there's no chance of seeing the sun.
Yeah.
So
but that doesn't mean you won't get a chance to have a look. If it seems that it's brightening up, you can even see it through the thin cloud. So
exactly.
as I said, just be very, very careful. Take images with your phones if you can, but remember, when you do images with the phone, make sure you do it through cloud. Don't do it direct because you'll mess up your phone.
Absolutely.
So
absolutely.
Take care, everybody.
And thank you all for your thanks. Much appreciated. We love doing this for you. And just a reminder, if you'd like to submit your images to the gallery, the address is gallery@spaceoddities.space. 1 image per email, please, if you would be so kind. Don't forget as well that you also get your own little gallery on the Space Oddities website, which is spaceoddities.space, if you submit images. So have your own gallery, and there we are. And thank you, Kenneth. Thank you for your information about the sun. Very, very useful. And we will be back next week on April the 1st, April the Fool's Day, when to inaugurate Moon Month here on Space Oddities, we will be discussing the issue of moon landing deniers. So I'm sure you'll all have something to say about that. We certainly will. And that should be, as they say, an enjoyable and lively discussion. So
we'll see who the Einstein of the week is on the panel.
Yeah. I've got my nomination.
Who's the denier?
Yeah. So there we are. So we will be discussing the whole business of moon landing denial because it's getting out of hand. Basically, it's any time on social media it seems that anything to do with the moon landings is even mentioned. The people trying to discuss it are vastly outnumbered by people denying the whole thing ever happened, and it's getting a lot worse. I don't know why, but perhaps we can discuss that next week. All right, then. So from all of us at Space Oddities, thank you so much for being here. We do appreciate it, as always. Have a fantastic week. Take care of each other. Be good. And if you can't be good, be average, as I always say. So we will see you this time, 8 o'clock UK time, next week on Space Oddities for our discussion about moon landing deniers. And we hope you'll all contribute to that discussion. So take care of yourselves, guys, and thank you for being here. From all of us, a very good evening to you.
Okay.